much. Uh, Hello everyone, let me just share my screen. One moment. Okay, can you see my screen?
Yes, the screen is visible
Okay,
and clear.
okay, thank you so much. Okay, today, as Edwin said, we are going to have some tips and tricks to master the CSWA simulation exam or any other simulation exam that you will encounter. So, just a brief introduction of myself. I am Sdiri Jamel. I am a SolidWorks application engineer at ABBK Physics Works here in Tunisia. I am a SolidWorks expert and I got also a SolidWorks simulation expert recently. So, starting, I want to do like introduction for the main steps of each simulation that you will encounter. So, for each simulation, for any type that you will do, first you need to apply, for example, you need to apply your material. After that, you need to apply the boundary condition and the load if they are existing. After like setting up your material, your boundary condition, your load, you are demanded to create a mesh, refine the mesh depending of your part geometry, whether you want to have like to get like stresses or displacement in a certain location. After that, after setting up all these details, you will be moving on to running your study and after that analyzing your result. So everyone, you should find like a link that I've put it in the chat. I don't know if you get it all or no. It's this link here. In this link, you are going to find this file, part file. It includes 5 parts and also the step version of them. If this version doesn't open, you can check the step version. You just only have to drag and drop it in SolidWorks. Okay. I will start, for example, creating a new simulation. I go to the simulation tab. If you don't have it, you go to the SolidWorks Edine. Then check the SolidWorks simulation Edine. Or you go here to add-ins and check SolidWorks simulation to add it to your Windows. Then we go to simulation and we create a new study. Here we have all the different type of simulation that we can have. Mostly for the CSWA exam, you are only doing static simulation. For the CSWP simulation exam, you are having some static simulation and some frequency simulation. Then when you are moving on to the expert, you will get in some view of thermal simulation, nonlinear and dynamic simulation. Okay, today I will focus on static simulation. I will choose a static. We can name it here, for example, uh, example 1. Then I will check OK. As I said, for the first step is to apply our material. We can either apply our material from this button here, or if I have multi-bodies in my part, I can just click here the body that I have here, then click apply or edit and edit material. Let me see my first example here. We have this connecting rod. The material is going to be aluminum, 1345 alloy. Let me search for this material. It's going to be in the aluminum alloy library, and it's this one, 344 alloy. Just click apply and close. You will notice a slight change in the color of your piece and of your part, which means your material is properly applied. After that, we will move to the boundary condition. What does mean like boundary condition? It means like how my part is like fixed, or what are the restraints that my part have. For example, in this part we have like the cylindrical face over here is fixed, that it does not move along the three axes. It does not have like a translation or either or any rotation on these three axes. So we go to the fixture advisor. I just click this arrow here and choose fixed geometry, or either I can go to the fixture here, right click it and choose the fixture that I want to apply. I'm going to choose fixed geometry, for example, as I said. Then I'm going to select this face. As you can notice here, the symbols in green, it means like the arrows, it means that it prevents translation in those directions. And the circles at the end of them, it means that it prevents rotation in those direction. So I'm going to click OK to apply my fixture. After that, we are going to move on to the load. As I said, we can choose external load from here, right click it, choose the load from this table, or either go to external load and choose it from up here. So in this question, what I have, we have a force of 500 Newton applied on both faces as shown here in this direction. So I'm going to choose force. Here we select the faces. I have this one and this one. Then here I have my force value, which is 500 Newton. Depending on your system, on your unit system, you can change it. For example, in pounds or in kilogram force. I think this one. So I'm going to keep the virtual system. I'm having 500 Newton. I have, no, I don't want to select this face. I have to reverse the direction, to click reverse direction. Then I click OK. So now the first steps are completed. I have my material, I have my boundary condition, and I have my load applied. So I will be moving on to the mesh. What does the question say? Create a mesh and use the default size mesh. So I don't have any like special mesh I want to apply. Just go to mesh, right click it, then click create mesh. Or when it says like this default mesh, you can just go click run the simulation and it will automatically create the mesh. But for this example, I'm going to show you what do we have as option in the mesh. I'm going to click create mesh. Here we have the mesh density. The more finer your mesh, the more accurate your result. The more coarse your mesh, you are going to get like less accurate result, but much faster time in simulation. Because like when you have more denser mesh, it's gonna take more time to finish the simulation. So I'm going to keep it as default. Here in the mesh parameter, what do we have? We have the three types of mesh. For example, standard mesh. We have curvature-based mesh and blended curvature-based mesh. These are depending on the shape of your part. So I'm going to set it, for example, for this blended curvature-based mesh, because I have a lot of curves here in my part, so it can measure them properly. For this value, the element size, maximum element size, and the minimum element size, I'm going to keep them as default because it doesn't set anything here. In the advanced option, what do we have? For this parameter, you don't need to, uh, to change them. For the mesh quality, it says keep it as default. You don't have to change to draft element type. So I'm going to keep it as default. Then click OK. As you can notice here with the blended curvature mesh, I have much more better mesh on the curvature faces. Let's edit our mesh, and now I'm going to use the standard one. See the difference? You can see here, like it doesn't like refine the mesh in the curvature region. So I am going to keep it as blended curvature based mesh to have much more smoother surfaces like this, as you can see. So now I'm going to run this study. It's not going to take a lot of time, as you can see, it runs fast. So now for analyzing our result, what does it say? It says what is the maximum volumetric stress of this rod. So the typical question that you are going to find in the exam are what is like the maximum volumetric stress, what is the maximum resultant displacement, and also it can ask you what is, for example, the maximum resultant what is like the maximum displacement in some specific direction, for example, X or Y or Z, or also for the stress, what is the normal stress in the specific direction. So we are going to keep it simple for this question here. I want to know what is the maximum. So to be able to show this value, what are you going to do? Well, we click, we right click the stress, we go edit. Here we change the unit to megapascal. It's already defined for megapascal. Here we have said we can change it to normal stress in either direction. I'm gonna keep it for meso stress. And just need to check the maximum annotation to have the maximum value here, and to better read the value here in the I'm gonna change it to floating to better read the result. 3 decimal, I'm just gonna keep it 3 decimal, then click OK. For example, my result for this part here is 18.572 megapascal. So does everyone got like the link? Could you all download like the file and the link and give it a try? Hello? Because I know it can get like a little bit fast for the explanation. So if anyone has any question, it can ask me while I am showing the steps.
No, sir.
Okay.
No, sir.
Okay. Did you get like the parts in this link? So you can repeat the question later. I will also send you this at the yes, the link is working and okay. Yes, I will send you also this presentation later. Okay. I'll be moving on to the. Let me just continue on this one, then I will move to the second question. Okay. For example, now it asks me what is the maximum resultant displacement. So I'm going to double click displacement to show displacement plot. As I said, we click edit definition. We keep it resultant displacement in millimeter. Here in the chart option, I'm going to check only show max annotation to have the maximum value. And I'm going to change my value format to floating. And my decimal number, I'm going to keep it 3. I click OK. As we see here, we have a displacement of 0.027 millimeter. So another typical question you are going to have is, this is like the most tricky one that everyone could fail. It says like, for example, the first question is going to ask you, what is the maximum resultant displacement? We have this value. I'm going to type in this value, and my first question is okay. So the second question is what is like the von Mises stress at the same location of this maximum displacement. So to get this result, what I do, what I have to do, I need to know the number of this exact point here. So to get that, I'm going to click plot tools here over here on the top and choose probe, then keep it at location. Then I'm going to select this exact location. Where is my point? Where I have my point. So as I see here, I have the value of the same value, 0.027 millimeter, and I have here the node number, which is 22085. So I need to memorize. Let me just type in this value. It is like 220.85. Then I click OK. Now I go to the von Mises stress. I also click probe, but now I'm going to select at node number. So now I'm going to specify the same number, which is 22085. Then click this button, which is probe result, to have the value at this exact location, which is 1.004 megapascal at this exact location. Excuse me just for a minute. Just a second, please. So sorry for the interruption. Okay, what I said last. What has I said? Okay, for the showing the maximum resultant, showing the maximum Hermitian stress at the same location where is the maximum displacement. So I'll be moving on to the second question, and I will do it again. So for this part here, I'm going to open this part. Let me just close this one here and open this one. I'm going to use, for example, this calculation. You only just have to drag and drop it. Sheet metal part, where is it? The sheet metal part is from here. Just drag and drop it in SolidWorks like this. I said no. Okay, let me start a new simulation. It's always going to be static simulation. What do we have? We have the first step, apply our material, which is alloy steel. Let me apply my material. I'm going to choose alloy steel, apply and close. Now for the second step, apply the boundary condition. We have that these faces, both the back cylindrical face is fixed, and both these cylindrical faces are fixed hinge. What does it mean? That they have they are free to rotate on their axis. Okay, let me start with the fixed condition, fixed geometry, then click OK. Now I'm going to choose fixed hinge. As you can see in this image, it explains what is this restraint. Like for this face here and this face here, they are allowed to rotate on their axis, but they are not allowed to translate or rotate on any other axis. So I'm going to click OK. Now for the load, we have a 500 Newton load on the top face. I'm going to apply a force on the top face of 500 Newton. It's in this direction, it's correct. Okay. Okay, now I'm gonna validate. Then for the mesh, we are going to use the default size mesh. As I said, we can just click run the study and it will automatically create the mesh. Okay, now what do we have here? I have that. What is the maximum Voumese stress? The maximum Voumese stress, I just have to edit this value format. I'm going to change it to floating and only keep the maximum value. Okay, and click OK. For this particular example, we have 71.968 megapascal. But as you can notice here, the result it says like 64 megapascal, and as you notice here, we don't have like the same result as in here. Here we have a sheet metal result, and here we have like a body result. We have like a thickness. I have a thickness here, but in this image there is no thickness. So what is the issue here? So when I open it like with the step file, I don't get like the sheet metal predefined. As you know, for step files, you only get like a body, an imported body. You don't get like a sheet metal part. So this particular case is only for this like example, but in the real case in the exam, you are going to get a file with a version of SolidWorks 2012 that everyone can open it on their SolidWorks version. So I'm going to erase this and I'm going to open the file that the correct file where there is like the sheet metal properties, as you can see here. Now, when I create a static simulation, you can notice the icon has changed. It's treating like my body, it's treating it as a sheet metal. It's not treated as a body because when I click here, I have like treat as a solid. You are going to treat this part as a solid. Treat as a beam. This is not a beam, like we don't have to treat it as a beam. Treat as a remote mass. It's not a remote mass. So the other option is treat as a sheet metal because it's already a sheet metal here, as you can see in this icon here. So let me apply the material and the boundary condition again. We said we have fixed here. We have fixed hinges on these faces here. Then I have a load of 500 Newton on this face. Yes, like for the step file and the correct version file, you can have a slight difference in the results, and also between the sheet metal result and the body, the solid body result, there is a slight difference in the result. So let me run the simulation. Mesh failed. Why? Because I think I didn't apply the correct mesh type. So let me put this type here, blended curvature based mesh, because I have some radius like curvature here, and they couldn't like get meshed with the standard mesh type. They need another type, like the blended curvature mesh. And as you can see here, my body is a surface body, it's a sheet metal. So let me run the simulation. As you can see here, it has a thin layer, it doesn't have a thickness. So let's plot the maximum. Let me have my value for not plotting. Oh, I think we got like almost the same result. Don't know what is this one. I think it's maybe an error here. We just delete it. So I have like which is 78 point. So I'm going to do, like, we are going to do the same example, but in the other direction. So I'm going to get the maximum displacement. Let me just go click edit definition, keep it resultant displacement, and change this to floating. Click OK. Like the minimum displacement is 0.035 millimeter. Now I want to get the von Mises stress in this exact location. So what do? We go to plot tools, we click probe. Either we can go click results, and I think we have a probe option here, or no, over here. And I click displacement, I have the probe option also here. So we keep it at location, then we select this exact location. How I know that I am correct? I am going to have the same value as my value here. And we have the node number, which is 183. I click OK and go back to stress, then click probe. And now we select that node number and I type in my value 183 and click probe result. So for this exact location, we have a von Mises stress of 50.273 megapascal. If this is this like trick is clear, because you are going to have it a lot in the exam. Is it clear, guys, or no? Hello. Does anyone have a question regarding this method? How to show the von Mises stress at the location where is like the maximum displacement? Let's clear. Okay. Okay. I'm going to click OK. Then I'll be moving to the third example, which if you work in the exam, you're going to have a specific part similar to this one, where you have a solid body and a surface body part. So this one is a little bit tricky, so I want to advise you to follow it like with me. Let me just close this one and open this part, the mixed mesh part. As always, we have a static simulation. Okay, now the tricky part. So, as we see here, as I said, we have 4 surface part and the solid body, as you can see here. If you open this one, we have a solid body here and 4 surface part. And the trick is that the solid body is alloy steel and the tubes are plain carbon steel. So let me just, if I click apply material here and for example choose alloy steel and click apply, I'm going to have the same material for all the parts, but for this one I have a different material. So we have to click this body alone, we choose alloy steel for this one, and for these 4 I can select them all 4, then click apply material. Since all they have the same material, and choose plain carbon steel, then click apply and close. You can see here alloy steel for the solid body and plain carbon steel for the surface parts. Okay. Now, for what do we have else? We have that the top edge of the tubes are fixed. The top edge are fixed. So I'm going to the fixed geometry, and here I'm going to choose all the top edges. Since we don't have any flat surfaces on the top, we only select those edges. Make sure to select them correctly to do not have any bad results. So click OK. Now, for the load, we have a 500 Newton on the bottom face here. I have a load of 500 Newton on this face, but in the opposite direction. 500 Newton. Then click OK. So now what I have to do, like there is a node, like the tubes and the base are bonded, and also have a thickness for each tube. For example, the tube A, the thickness is 2 millimeter, B is 0.8 millimeter, C is 1.2 millimeter, and D is 1 millimeter. So let me start with the thickness of each tube, then I will be moving on to this node. This one is very important to have like a correct result after. So let's start with the thickness. For the tube A, which is this one, just click it and know its location here, and click Edit Definition over here. Then choose thick and change its thickness to 2 millimeter. Click OK. Now for the tube B, which this one, 0.8, just click it and right click it here. Thickness of 0.8 millimeter. C, which this one here, 1.2 millimeter. C is this one here. Thickness of 1.2 millimeter. And the last one is this one, which is with 1 millimeter. Edit definition. Thickness of 1 millimeter. Click OK. Now, as I see here, we have the thickness and the material of each one, like this. Now we move to the node which says the tubes and the base are bonded. So we, as you can see here, if I put a front view here, we can see that there is a gap between the tubes and this plate. So I need to set like a restraint that these edges are bonded to this face over here. So to do that, we need to go to the connection advisor. We select local interaction. Here in the local interaction, I change this one to bonded, to the type to bonded. Here in the first case, I select the bottom edges of these tubes. Make sure to select them correctly, like this. Make sure to select them all. And this one here, no, only the bottom edges of the tube. And in the second one, select the top face of the plate, then click OK. Make sure to change the type to bonded and click OK. Now for the mesh, it says use default mesh. It's going to use a shell mesh for these tubes because they are surface body, and a solid mesh for this one because it's a solid body. So I just click run the study. As you can see here, for the tubes, it's used the shell mesh, and for this one we have a body, like a full body mesh. I can click deform the result to have the exact deformation. So what I have as a question, what is the reaction force on the cylindrical tube D, which is this one? Okay, this is another type of question. So the reaction force, where does the reaction force occur? It occurs at the place like where is like the boundary condition applied. So I have a fixed boundary condition here, so I will get the reaction force on this exact edge here. So how to get the reaction force? I need to go to the result advisor, click this arrow here and select list result force. Then choose reaction force and choose this circular edge here. Then click update. I'm going to get this table here. For example, we have the resultant reaction force, which is 139 Newton. If it asks you about a specific resultant force in a specific direction, you are going to have it here. For example, the reaction force in the x direction is minus 0.032 Newton. For example, the reaction force in the y direction it's 0.404 Newton, and the reaction force in the z direction is 139 Newton. If it asks you, for example, for the resultant reaction moment, you are going to get them below, but in the CSWA exam, you are not going to get asked about the reaction moment. You are only going to get asked for the reaction force. This depending on the exam you are going to get, because like as I said, there is several parts, and each one is going to get a specific part for his own exam. But this is the common example you are going to get in the exam, and one of the trickiest ones that people mostly failed because they also always forget to set the bonded position between the bottom edges and top face of the solid body, which leads to errors and bad results. And also, they don't know where to get the reaction force. Going to be, as I said, in the location where you apply the boundary condition. And to get it, you need to go to the result advisor and choose list result force. One reaction force. As I said, again, I applied the boundary condition and click update to get the resultant reaction force. So I hope this is clear for this example. Do you have any question for this specific one? Please, can you show us the default mesh type so we can get the same result? I mean, is it standard? Yeah, I think it runs with standard mesh because it's the default mesh for me. So I click OK. It's standard mesh. And I didn't change the density of the mesh. What is it? What if the thickness of the surface body first with the respect thickness value and do the setup? Now having multi-bodies, will I get the same result? Yes, you will get the same result, maybe a slight difference in the decimal part, but you are getting the same result because it's the same geometry and the same boundary condition and the same loads. If you apply the same thickness for the circle, you are going to get the same results. But if you change the thickness, you are going to get other results. Okay, thank you. Okay, so I'll be moving on to the fourth application, which is another example of the part. It's a simple one. I'm gonna do it quickly. Let's open the part here. Create a new simulation. As always, like simulation. What do we have here? We have the material alloy steel. We have all of these bolt holes are fixed. We have a force of 460 Newton on the circular face in the bottom direction. We are going to use the default mesh, and I want to know the maximum resultant displacement. So we are going to repeat this process again. First, you apply the material, which is alloy steel, this one. Click apply and close. Okay. The second one is the boundary condition. I'm going to choose fixed geometry. I'm going to choose all for surface. This is here. like this, and click OK. Now, the third step is applying my load, which is a force of 460 Newton in the minus direction, which already okay. You don't have to reverse the direction here. Click OK. Then I'm going to keep it as default for the mesh. Maybe I have to change it to blended curvature mesh because I have some fillets here with a small radius that will not be good with the standard mesh type. So I have to change it to blended curvature mesh. Let's see the difference. If I keep it to standard mesh, let's see the difference. For here, I think it runs mostly perfectly for these parts, but not as good as the blended curvature part. As you can see here, we have an extra like refinement on this specific area where there is like curvature, where there is like curves. Let's see the third type, curvature based mesh. As you can see here, we have much more refinement for the curvature faces. So I'm going to keep it a blended curvature based mesh. Click OK. Then I'm going to run the study. And now for the results, I want to have the maximum displacement. We click edit definition. Keep it in millimeter. We change this one to floating to better read the results. And I want to increase the decimal number to 5 to have a clear results. Let me just show the maximum annotation only. We have this result, which is 0.08879 millimeter. So, for example, if it asks me what is the von Mises stress in this exact location, what do we have to do? We have to get the node number of this exact location. So either I click plot tools and choose probe, or I click displacement and choose probe also. I have two options. So we keep it at location. Let me select the exact location here. To make sure that I'm correct, we read the value. If I have the same value here, so my point is correct, because in some cases, some people click on other location and have other like node numbers. So my node number is 2552. We close this. We go to the von Mises stress. Then we click probe. Now we select node number. We have 2552 and click probe result. So for this exact location, yes, let me just change the value format here to better read results, because like this is another common mistake that people make. For example, they keep it scientific, like keep it like scientific, and they only like write 1.62. They don't know how to write e minus 0.2. So the trick is that you need to change the value format to floating. Then click OK. Now let me read the value again at node number 2552. So now my value is 0.122 megapascal. You need to write this value. You don't need like to write 1.22, and which gonna be like a false result. This is one of the most like common mistakes that people do in the CSWA simulation exam. Let me just click OK. I hope like this process is clear how to get like the maximum displacement, and after that how to get like the von Mises stress at the same location. Like, is it clear for everyone? Okay, I hope it's clear for everyone because it's a tricky one. Like you need to get it right. And as I said, you need to change your value format to floating to better read the results. Okay, let's move on to the last example. This is like a bonus example. It comes in the CSWP simulation, but like it's better to know it now than after. So for this example, we are going to treat like beam type parts. So let me just like get the step 5 for this one. Click no and let me break the links. So as we see here, we have 3 imported bodies, but I cannot have the right to change anything for them. So I'm going to create a new static simulation. So as I can see here, they are all treated as bodies. So I want to treat them as a beam. Like for this part, we have them like all of them are still ASI 1020, and they are part 2 and 3 are treated as beam, and part 1 is as truss. What does it mean truss? Which is like a beam, but only support only axial loads. So let's start with changing their property. So I will select them all and right click it and treat selected solid bodies as beam. I'm going to change them as beam. Click OK. As you can notice, like the icon next to the name has changed to beam. So the only thing is I have to change this one here to truss. So I have to click it, right click it, and click edit definition, and I change the type from beam to truss. I wanted only to support axial load in this example. I click OK. And also you can notice the change of the icon to truss icon. So let me apply the material. Since all of them have the same material, I can just click here, apply material, and ASI 1020, click apply and close. So now for the boundary condition, I have like the joints A and B are fixed. Those one, like for beam bodies, like when you treat a body as a beam, you notice like there is these dots over here. These are like, for example, the end points of beam, and also the connection point between two, like this one and this one. This is the connection between them. This one and this one also. And these are the endpoints of this beam, and this is the endpoint of these two beams. So it says like we have a fixed geometry for these two joints. So as you can notice, we're having joints selected here, and when I select these two dots. Click OK. Now for the load, we have an applied force of 3000 Newton on beam 2, on this beam. Since it says on the beam, when I apply the force, I have to select, we have like 3 options, either a vertice or a point, or either a joint, or either the beam itself. So I have a force on this beam. I select beam over here, then I select this beam. Is it the same one? Beam 2, this one, okay? Here I have to select like a face or a plane that I want to select as my reference plane. So here I'm going to select like the top plane as my reference. Then I have like a force normal to the top plane of 3000 Newton. as it shows in, and it's in the Z direction. Then I click OK. I don't have to reverse the direction here. Now for the second, I have a force of 270 Newton on the joint C from beam 3. Now we have a force applied. Select force. Here I select joint, then select this point here. It's this point here, and it's 200. I have to select either a plane, or I can select a face, this face for example, and 270 Newton direction, then click OK. So now my force is applied, and the force on the beam also is applied. The boundary conditions are applied. For the beam type element, the mesh is like 1D mesh, one dimension. So it's only treated as a line. You will notice later when I run the study, they all treat as like a line. It doesn't like take in regarding like their shape. It's like a method of simplification for beam element. So if I click show the mesh, you're gonna see it's like only straight line. It doesn't take like in regarding their shape. So now I am going to move to the question. I want to know what is the maximum von Mises stress and what is the reaction force in the joint B. Okay, what is the maximum resultant maximum von Mises stress? I click stress. Here I have to click edit definition, and I need to change. Sorry, yes. For this is like an error here. Like for beam element, we have like different type of stress that will apply. For example, we have axial stress, we have upper bound, axial and bending stress, we have a torsional stress, we have shear stress. So I am going to select, for example, the axial stress applied on the maximum axial stress for this body. For this example, I am going to select show floating value, keep this for 3 decimal part, and only show the maximum value. Since this part only support axial loads because it's treated as stress, we will have like the maximum axial load on this body here, which is 58.653 megapascal. If I see, like for example, the upper bound axial and bending stress, it's gonna occur. No, it doesn't. Yes, keep this one megapascal. If I click this option here, it will show me like a small rendering for the beam. Let me just keep in the maximum annotation and click OK. Yes, as you can see, it changed like it renders the beam and it shows its actual format. And also, I got the same like value on the same location for the upper bound and bending stress. Okay. So one other trick is showing the reaction force on the joint B. So as we said, for the reaction force, they only occur where the boundary condition is applied. So I have to select the joint B, which is the bottom one, this one here. Then click update. The resultant reaction force, which is 3.26 10 times 3 Newton. So I need to change the value format. It's already changed to floating. No, sorry. Click update. don't know. Oh yes, it's over here. You can find the working format over here, which is 3,257.4 Newton force. If it asks you about the reaction moment, you're gonna find below. For example, the resultant moment, the reaction moment on this joint 108.72 Newton meter. So I hope these examples are clear. So I think I'll be moving on now to the Q&A. If anyone have like any question, can ask me to clarify any parts of these tricks and tips for the exam. Hello everyone. Does anyone have any questions? Yes, you can ask me. What is it? When it is not defined, how you can choose the best type. The best type is regarding your your geometry. For example, for let me just open a like for these like type of parts which they are originally are profiles or beam. You are simply recommended to choose the beam type mesh to make it easier for you to calculate the results. And for the other types, like let's open another part. For example, this one here, where it has small curves that you want to have like when you that you want to include in your simulation. Here in this example, you need to choose like the blended curvature based mesh or the curvature based mesh. This one is like a combination between the standard mesh and the curvature based mesh. It's the most common one to use for these cases. But if you have like more rounded parts with a lot of curves, it's mostly recommended to use the curvature-based mesh. If it is a simple like geometry part, you only use a standard mesh. And now for the mesh density, like if I click OK now, let me see how many elements I have in these curvature. As you can see, I have like one element here. So if I want to get much more accurate results on these parts, I need to have more than one element. I need like to refine the mesh. For example, I refine it as maximum as possible. It's going to take a little bit of time now to creating the mesh. And as you can see here, we have like two elements here. So if I want to have like more elements on this region, I need to to create a control mesh, which is this one, apply control mesh, which is like creating a specific mesh for this. For example, for this face here, I want to have more more elements. So here I specify like the maximum element size. I'm going to put it like 0.5 millimeter. And the minimum element, I'm going to put it 0.1. Then click OK. Now I will click create mesh again. It's gonna take more time, less time, because there is more elements on this region here. As you can see here, we have like 1, 2, 3, 4, 5, no, 4 elements on this, only on this region here, as we have like 2 elements on the other region over here, because I refined the mesh for this specific area here. Like these tricks are mostly used to have much more accurate results on a specific region that you want to predict the stress value on these regions, or you want to predict the displacement on this region. Does, like, for example, is it going to fail on this specific region here, or do I need to have like to change the geometry here to have much more stable parts? It's all like depending on your application and on your geometry. But for the exam, you will not have like you don't need to change them. Okay, but which one of them? Like you use it the blended, but I think curvature is the best one. Yeah, like I use the blended one because this part is not mostly like curvature based mesh. Like it's not mostly curved part. If you have like part where is like mostly like have like curved faces, I recommend using like curvature based mesh. But if you have like a mixed part here, like there is like flat surfaces here and over here, and I have a small like pellets on these areas. It's mostly recommended to use like the curvature blended mesh, and you can also you can use like the curvature one, not the blended one. Okay, it's also up to you what type of results you want to get, and how accurate the results you want. Like, is it like a quick result that you want to see if like is it going to fail or no, or you want to get like specific values on this region? You want to get the exact stress value on that region. It's depending on your application. Okay, thank you. Does anyone else have any question? Hello, everyone. Yes, I will share the link to profile. If you have a message, click again. And also, you can scan this QR code over here to get to the LinkedIn profile if you want. Let me just save this presentation to send it to you. Thank you. Do you have any more questions? No. Okay. So I think that's it for now. For me, I showed you most all of the tricks that you will encounter regarding during like the exam. I hope I wish you all the best for the exams, and if anyone have any question, you can ask me now, or you can send it to me like via my LinkedIn profile. So Edwin, I think we are done now. Do you have any question or anything else?
Yes, Jamil, thank you for the
Yes.
session.
Thank
It
you so
has
much.
been a wonderful session on my side because I have gained more, and despite that, I've been doing more simulations, but within this session, I have gained a lot of int expression when it comes to the mesh properties, curvature mesh, and how to deal with different parameters. So, in my point of view, it has been a powerful session, and whatever aspect is being projected within the CSWA, it has been perfectly highlighted upon. Same in the same way also for CSWP simulation. I've seen some int that
It's
are
like
being
yeah,
asked.
I've showed some hints for the CWP. Like maybe if they want to pass the CSWE, we can arrange another session for specifically for this simulation exam.
Sure, sure.
I
Let me put to my calendar and we'll see. So thank you members for the wonderful attendance, for the wonderful turn up. I have shared a link in the chat for the certificate of participation. And thank you for attending. Thank you for joining in. I I also want to thank Deepak Gupta, is also SOLIDWORKS Zero, also other SOLIDWORKS user group leaders like Jasmine is within, Vincent, Abdul, all members from the different continents. Thank you for turning up, and also the different engineers, designers on the platform. So you can feel free to fill in the form as we shall be looking for the next session is to come in as Uganda SWUG and as part of the SWUG. I appreciate Jamel also for accepting my invitation, and also great appreciation to ABBK for the wonderful
thank you
work
so much.
being done.
Thank you
Yes,
so
thank
much.
you
Thanks
members.
anytime.
Yeah, the recording is going to be uploaded today on the YouTube channel, and I will be sharing the link. Thank you. Let's keep in touch. In case of any problem, any challenge in design simulations, yeah, you can reach out to the different people. Either you can reach out to me, you can reach out to Jamil via the LinkedIn, and also the park is within, Jasmine is within, Vincent, Innocent, everyone. Thank you for attending, but make sure that you fill in the form. I wish you the best.
Thank you so much, everyone. Thank you.
Okay, a nice time all. You can leave the session at your own time. Bye bye.
Have a great day. Bye.
Okay, have a good day too.